Good evening everyone. Today I am discussing about laws of thermodynamics. Okay. There are three types of thermodynamics, and first law, second law and third law, and the zeroth law is a neutral one. The laws of thermodynamics are a set of scientific laws which define a group of physical quantities such as temperature, energy and entropy. Okay, the major part of the physical quantities are in this laws of thermodynamics of scientific laws. The physical quantities are temperature, energy and entropy. These are the major parts we use in the laws of thermodynamics, and it categorizes thermodynamic systems in the thermodynamic equilibrium. Okay, and here in this picture, zero law, first law, second law and third law. There are three types of thermodynamics where zeroth law is a neutral one. Okay, and in this the laws also use various parameters. It use various parameters to process thermodynamics such as work, heat and establishment relationship between them. Okay, there are recognized into three types. Yes, I said you before, thermodynamic zeroth law, thermodynamic first law, thermodynamic second law, thermodynamic third law. You will see forwarding by the video. Okay, so I'm explaining about thermodynamic zeroth law. Actually, this thermodynamic zeroth law defines thermal equilibrium, and it forms a basis of temperature whose two systems in this thermodynamic zeroth law. Also there are two systems are each in thermal equilibrium with a third system. Actually this is related to the third system. Okay, and here I am discussing about again first law of thermodynamics. Okay, it states that when energy passes into or out of a system as work, heat or matter. Actually what it happens, it passes energy out of a system as work, heat and matter, and the system's internal energy changes. Here changes is the word which changes internal energy to law of conservation of energy. This also results in the observation that in externally isolated system, even with internal changes, the sum of all forms of energy must remain constant, as energy cannot be created or destroyed. Energy cannot be created here or destroyed. Okay, this is the first law of thermodynamics image, and here energy cannot be created or destroyed in this first law. Okay, and here by seeing this equation, what is w? W is the work done. Okay, and q is the heat observed. I'm writing over here, w is the work done and q is the heat observed. Okay, yes. Next, we'll go to the second law of thermodynamics. Here, the second law of thermodynamics states that in a natural thermodynamic process, actually, it is a natural process of thermodynamics. The sum of the entropies is interacting with thermodynamic system. Sum of entropies is interacting with the system, thermodynamic system. It never decreases. This is the main point you used to keep in your brain. Okay, next, the common system that heat does not passes from colder body to a warmer body. Here the heat does not pass from colder body to warmer body. Okay, by seeing this image, second law of thermodynamics, here entropy of any natural and spontaneous process either increases or remains constant. Here heat flow from a hot body to a cold body. Okay, next, this is the second law of thermodynamics. Next we are going to the third law of thermodynamics. Third law of thermodynamics states that a system entropy approaches a constant value. Here entropy approaches a constant value, I mean it's a C, okay, as the temperature approaches absolute value. Here entropy approaches constant value, temperature approaches absolute zero, with the exception of non-crystalline solids. What is non-crystalline solids? I mean ice. Okay, the entropy of a system at absolute zero is typically. Third law, entropy of a system approaches constant as temperature approaches absolute zero. Okay, and this is the third law of thermodynamics. These laws of thermodynamics are very important for physics and chemistry also. Thank you. Like, share and subscribe. Online tuitions available for every stream with reasonable fee, and join Telegram channel given link in description. Thank you.